Hey everyone, glad to have you here assisting another event under the initiative GDG Tech Sessions. Here, Carlos Jabril from GDG Madeira, introducing these sessions for you. With these sessions, we intend to keep sharing knowledge about diverse tech topics from speakers around the world and make it available independently of where you are. So feel free to replay and share the previous tech sessions at our YouTube channel. We hope that you enjoy a lot what we've prepared for you. Before starting with the session, don't forget that if your community also wants to propose a text session, just fill this form and we will contact you to further details. The speaker can be from your community or a friend of yours with content and skills to share. Keep in mind that if you can always propose an event, even if you don't belong to a GDG chapter. These tech sessions can also be proposed for any GDG women tech makers or GSC that have some content to share to the community. And today, Abdallah Abedraba, previously as DevRel at Google and now as a backend developer on GreenMobility, will introduce to us about GraphQL. But also, there is an opportunity that we have to know a little bit about GDG Jaén and their community through Ismael. Just to remind that we will use the Slido platform in order to facilitate your communication with the speaker. Just pour your questions and they will reply at the end of each of this talk. Like before, the link is in the description of this video. So without taking much more time and before starting the GraphQL tech session with you, Ismael from GDG Jaén.
Hello guys, I'm Ismail. As I've been presented, I come from GDG Jaén as well as Abdallah. I'm currently working in Google. I just started in the foreseeable section, like the cybersecurity part. And I'm gonna talk to you about how the community is important and how GDG Jaén has helped us so much and has got us so far by now. Oops. But first, what's GDG? Here we can see a picture that was taken from us from the top in Mountain View in the general offices of Google last year in the Google I/O 19. Yeah. Previously, before all the COVID happened and we could all be free and enjoy and meet people without masks and all of that. Maybe you can see here any Portuguese flag, or I don't know, I can see Brazilians and so on. I can actually see the GDG Spain flag. And yeah, it was amazing. And the point is, GDG is basically community. And you can have many communities. You can build as many communities as you want. But GDG is supported by Google. And that means that if you want some guide or you want some support, because you're not an expert in this about communities in management or so, you have the help of Google. So trust me, it's very worth it. Let's move to the next one. Here we have what GDG Jaén has made for us and for me. Like before I joined GDG Jaén and actually met Abdallah, I was this kind of hateful nerd, like the one that you're like, ugh, because I was like starting the university and I had the typical thinking about why should I share? Why should I give my code for free, for example? Why should I do that? Like, what's the point then on working? And then I met Abdallah and I got into GDG Jaén and everything changed for me. My life changed, my mindset changed. Like now I'm completely in favor of community, of free software, of open-mindedness, of everything. Like here we can see friends I made. Here we can see Abdallah, who's gonna give the talk, and I hope you enjoy it so much. Manuel, who is also from GDG Jaén in the first picture at the left. Tarek, who is from GDG, a section of GDG Germany. I think it's from Bayern. It's from Munich. and Amanda Cavallaro from London. So we could all gather in big events or even smaller events and make friends. And that's amazing. That's one of the best ways of making friends I already had. I haven't lived so much, but for me, it was an amazing way of making friends. It also gave me opportunities. In the picture below, you could see me. It's not very big, but I was presenting my first talk, and I was really shy, and I was pretty introvert. But then when I started in this community and I started meeting people, and so I started to become like more open, like taking more risks, and not caring too much about failure or what other people think about me. I just wanted to share with people. I just wanted to give what community had given to me, and it has improved my confidence so much. It has given me so many opportunities, and I think I'm here at my current job because of the community in a large part. And finally, in the last photo, in the one in the right, we can see one of the biggest events that GDG Jaén had. At that point, it was, I think, our first DevFest, and we gathered like more than 200 people. It has always been a huge success. Every DevFest we have celebrated, and it was something we can be proud of in Jaén, because we are a little town, not well, a little city, like 100,000 population, and gathering so many people interested in technology in that little city. It was amazing. Like not even Madrid or Barcelona or all the biggest cities in Spain could gather so many people for an event for a technology event like DevFest. So we really felt proud. And actually, that photo is taken from the first talk that Abdallah gave. And I remember I was like feeling like a child. Like I was feeling so good, like so passionate, so empathetic with him that I said, okay, I want to become this. And I hope that he inspires you so much with this talk that he inspired me. Now I leave you with him. You could move. And yeah, you can have Abdallah for just some minutes. Enjoy him. It's a very good talk. I've already enjoyed it. And if you have any questions or any contact you want to have with me or anything, you can contact me by Twitter, for example, IsmailPG10, and everything okay. Now I'll leave Abdallah continue with the talk. Thank you very much.
Thank you, Ismail, for the kind introduction. I'm not sure if I'm going to inspire a lot of people here, but that's a really nice introduction. And thank you for the GDG Madeira team for organizing these kind of events. This is free work that they're doing, and they're passionate enough to make events around it. Claps for you guys for organizing all of these. Let's get into the brass tacks. And today, as you know, I want to tell you a little bit about how I got into GraphQL, and just a kind of introduction to it. But first of all, I wanted to tell you my journey into GraphQL. So I started in GreenMobility a couple months ago. I'd say we are a startup that we do car sharing, electric car sharing in cities. So instead of having your own car in the city, you can actually find one of these cars, whatever you want, and take it from point A to point B. And that's the idea. And you just pay for what you used. So once you leave the car, someone else can come and take it. Or if it's still there, you can still use it after that. And as we are a startup, we are using, we're building some technology from ground up. And we were looking out there for interesting technology that could solve our problems, but also kind of we kind of enjoy also working with cutting edge technology. GraphQL is not cutting edge. It's been around for some time, but it's still not widely used in many developers. And I hope I can give you a kind of introduction to it, so you as well could start using it. This is going to be, again, I've just worked with GraphQL for a couple of months, so I'm going to share with you the process and the knowledge that I needed to understand how GraphQL actually solved this. So if you've already done some GraphQL in the past, probably this is a little bit fundamental. But I'd like to address a small problem that we have here that I think some of the people get wrong, and it's GraphQL versus REST. So usually when you're when you hear about GraphQL, everyone is comparing it to REST. That GraphQL is going to overtake REST, and it's going to be the API by default. And in order to see how much of a truth is there, we would like to understand a little bit from the beginning where we come from and what it actually solves, and eventually have a conclusion if GraphQL would overtake REST in the future. So we want to build an application, and this application is actually going to be GitHub. So we're going to have a user, and we were going to need a project and let's say followers at the same time. And we want to build the application from ground up. So we have the clients here in the left, which is going to be a mobile client or also a computer client. And that's why we're going to build an API so it can support both of them. We will obviously need the server to store, to contact and get the information from, and the database to store and retrieve the information. So if we wanted to make a request to the database, we would actually just request data through an HTTP request, could be. The server would process that request and store the data if you're actually storing the data, or get you the data. And then it will give you back a response. And the same goes for the PC client. So let's say, how do we actually want to retrieve that data from the database? How do we tell the server that we need that specific data? Because a solution could be, hey, dump all the information that you have in the database and I'll deal with it. But obviously, as you might think, that is not a very interesting solution. The idea is to create like kind of a language that you can speak to the server to, and with that language, you can express what you actually want. And this is what an API is. An API is just an application program interface. So think of it as the human language to speak to the database and to be able to get the information from. So let's say we wanted to create the GitHub application, which is actually already live. It's been in beta for some time. Maybe 3-4 months, but you can actually download it in your phone. And when we want to build this API, this application, we want to have like in one of the pages of the application, we want to have the name of the user, we want to have the list of the projects, and also the list of the latest followers of this user, just to make it a little bit more interesting. So let's say, first of all, instead of dumping the whole data, we're going to save the data one by one. So let's say we're going to save the user in one place and the project in another place, and the followers in another place. And a request, if we wanted to get the user, would look like this. We would construct a new verb into our language, which is the API, and the verb is get user. So the client could make a request just like this, api.blog.com/getuser. The server will then parse this URL and match the function with the function getUser. We'll match this endpoint with the function user, and then goes and gets the data and gives it back to you. So it actually returns the whole user information, the ID, the followers, and many more information. But what we actually need is the name. So in this case, to get the user, we just made a quick round trip, creating this function in the API and getting back. So what about the projects? Let's get the projects. So we get a new function, and in this case, we are going to say to the function the user ID, because like projects could be a lot of them. So we want the specifics of this user, and again, we send it to this URL. We add a query here. So this query is going to be matched to this parameter. The server processes it and gives me back the list of all the projects. Actually, here it says posts, but it's projects. And I get like all the projects that I have, but actually I just listed 4 of them. Imagine you could have a couple hundred projects. Well, the idea is that the server would return the whole thing. And finally, for the followers, we kind of do the same. We construct the verb, and we request it from the server, and the server gives it back. And the server knows what kind of information should be given back. And what we actually just did is create an RPC-like API. RPC is an API that has been around, I think, since the 1980s. It's called remote procedure calls. A procedure is just a function. So these are the functions in my server. And a remote call is just like the client doing the remote call to the server. But actually, the RPC's API have some problems that needs to be addressed somehow. And one of the problems is that it's tightly coupled. And what does that mean? That means that first of all, you don't have enough abstraction in this language. You cannot actually predict what would be the function. So for example, if the application was a little bit more complex and we had way much more functions here, you actually don't know how the server calls these kind of functions. And you kind of not only have to care about the data that you're receiving, but the implementation of the server, the details of the server, and how it is constructed. So that makes the client really coupled to the server, or this API, particular API. On the other hand, we have a low discoverability issue. Again, the same thing. How do you know what kind of functions do we want to retrieve? Usually, you would make a documentation. But also, some of the times, the documentation is not enough because there's no structure into the naming. And as I don't know who said it, but they said the two hardest problems in computer science is cache invalidation and naming things. And this is some of the things that happen. And actually, in RPC APIs, and actually doesn't give you a lot of information. On the other hand, if you were to use the API from ground up, if you're a new user and you wanted to use the API, you wouldn't have a start point on doing that. And we are going to address these problems later, by the way. And finally, it's hard to maintain, and that's because this API grows really fast. It's so easy to make new functions that solves a new problem. So if we added, like, let's say, a new field into the user, which is an email, we could actually just create a get user email, because it's really easy to create it. Or we can just even create a version 2 of the API. And this, on the long term, makes the API really hard to maintain and not very scalable enough. So what can we do to solve these kind of problems? So here comes REST, trying to solve these issues. And REST starts with the problem. Let's tackle the hard to maintain. So the problem of growing too fast. So REST is a representational state transfer. It's an API that's been around since the 2000s. And it actually is, let's say, an application pattern. It's not a framework or library, which we are going to address this later. But the main thing here is that we are going to change the actions into collections. So here you have the actions, which are these verbs, functions, get user, get projects, get followers. And we're going to convert them into collection of data, which is way much easier to understand. And also, it's very easy to link things together. So if I wanted to get a user, I would just go into /user/ the ID of the user. And I would get that user, specific user. But if I wanted to get the projects of a user, I just would have to do like /user/ID and projects, because projects is actually a property of a user, and it's nested inside of the specific user. And finally, if I wanted to get a follower, it's already here. As you can see here, there is way much more structure into what RPC gives you here. And you can actually model pretty much to a certain level what the database would look like. And this scales really well, because once it's built, the idea is that you cannot change these endpoints pretty frequently, or you cannot change the API. So it actually forces you into thinking about how to design it from the beginning and how to make it last for a long time. Some of these APIs also could last decades if built really well. And on the other hand, we have the tightly coupled problem. So as we were saying, in the RPC, we are leaking the details of the implementation of the API, and we have to know. Again, we have to not only think about the data, but also the implementation of how the data is got. But in REST, because it's built on top of the HTTP protocol, it actually gives us all the operations that we can do. So usually we get the get method, the delete method, the put, and the post method, but there are much more than these. But there's actually just a structure here that you can see. For example, if I wanted to get a user, I would do get user and get their information. But if I wanted just also to create a user, I would use this method. So this collection has a set of methods that you can apply to them, which makes the API not really tightly coupled to the client. And actually, many clients could just use it. Finally, the problem of low discoverability. As we were talking, the RPC, we don't know what kind of functions we can expect. We have to read the documentation, and it's not enough sometimes. But in a REST API, this is actually a call to the API, GitHub API. This is a real call. It's just a long list of things, so I just trimmed it. So if I make a GET request into the root, it will actually give me all the routes that this API supports. So if I wanted to get the current user, I would go to /user. If I wanted to get the followers, which was interesting for our application, I would just go to followers. And what about the projects? Do we have here projects? It should be in the next slides. But the idea is that you already have a way to start into the API without even needing the documentation, which is always obviously helpful. But you can actually make yourself around into here. So the request would be kind of the same. Just make a GET request into the user endpoint, and the database knows that it's a GET request, and it knows it's going to this endpoint specifically, so it'll give you the information. And actually, just so you can see it, this is actually a current, a real GET method into the API. So here we're doing a fetch into users Abedraba. The host is api.github.com. We have the login, the ID, the node ID, the URL of my user, the name, which was important for us in our application, the company that I'm working for, and some more information. But for our application, we just needed the name of the user. We actually don't need more information than that. So we kind of had so much data, but we're just using one field, which is the name here. And you can actually start seeing one of the problems that REST has. So actually, this is going to happen for the followers as well. First of all, we want to get to the user. And here, if we wanted to get to the followers, we just take this route, which would take us to the followers. So let's take this route, which is users Abedraba followers. It's here. And once I retrieve it, I actually get the list of all the users that I have. You can actually try this by your own, by the way. And as you can see here, this is an array of users, and this is just one user. I just couldn't put the rest of the users here. So it gives me the login, the ID, some informations like the repos, but it doesn't give me the name. And what I actually need is the name. So I'll have to go into the user URL and fetch the name from there. So I'm going to fetch the name from this endpoint. So I visit /users/staticHuber, and then I get one of my followers is, by the way, my good friend Tariq, and then I get his name from here, and then I can just add it to my followers list. But as you can see, I'll have to do this for all the followers that I have. So here, this is just one follower, and then I have another follower, which I'll have to go to their endpoint as well and get their name, and then another follower, and then the third endpoint, and this is how we can actually get the 3 followers that we had here, which doesn't seem very efficient, and we can address it later with GraphQL. And finally, the repositories. If you go to /users Abedraba repositories, you can actually see all the repositories that I have, which is a long list. This is just the information that you get for one project, and I'm not even able to fit it into the screen. So from this project, we just need the name because we're listing the information here. So we just need project 1, project 2, project 3, and 4. So literally the rest of the information, we just have to ditch it, and we don't take care of it. So if we make the sums here, we find out that if for the user request, we got all that information, but we just used the name, and that's 1.2 kilobytes. For the projects, as you saw, the list was really long. This is 150 kilobytes, and for the followers, we had to go to the followers endpoint, but also like for each user's page of the followers to get the names from there, which we had to make 3 of them. So there's a sum of 180 approximately requests to like kilobytes of information. And this is what actually is called overfetching. Like you're taking way much more information from what you're needing. Because again, we just needed the field of the name. We just didn't need the rest of the information. And if you see the state of the art of web development, for example, the Starbucks PWA, I think it had 230 kilobytes. So it's an entire web application built in at 230 kilobytes. And here 80% of the data is consuming in that. So there has to be a way to solve this. And probably 180 kilobytes wouldn't seem too much. But also imagine yourself being in a metro or in a train or in a really low coverage zone, and you don't have a good connection. So actually, then you'll be like, OK, I actually need this connection to be faster, and there has to be a way to fix this. And this is actually the problem that Facebook was encountering. GraphQL is created by Facebook, and as you can imagine, these people have so much information, and they want their application to be as fast as possible. So they needed a problem to solve this really slow application that they had back in 2012, I think. So the problems of REST API is that, as we mentioned, we have overfetching of information and underfetching, because just fetching the user's information is not enough. So that's underfetching, because we also needed the project and we also needed the followers. So we needed to go to these pages. But also, like all the information that it gave us back, it was like just too much of data. And this is actually overfetching the information. And here, I also mentioned the N+1 problem. What is the N+1 problem? It's actually the problem that we encountered in the followers endpoint. So in order to get the name of the followers, we had to retrieve the list of the followers and then go for each follower endpoint and get their name from there. So in case, so if the number of followers is 3, I'm actually doing 4 requests to the server. So that's back and forth to the server, going and retrieving that information. And we need to fix that in some way. And finally, there is a Restful-like APIs, which is a problem that I would like to address later. So let's focus in a GraphQL API and how would it solve this problem. So in a REST API, you use the user/Abedraba endpoint, and you get the data, and you would have the overfetching. But actually, in GraphQL, one of the main differences that we have is that we don't have many endpoints. As you see here, we have the /users project, /users follower, and we have all these methods that we can apply to them. GraphQL only needs one endpoint. And from this one endpoint, it will gather the information. How? We are going to explain it later. But the idea is that you don't need to have a lot of information on how the endpoints are built. If we can go back to our endpoints list, you can see that it's like a really big list of endpoints, and that usually is pretty hard to remember, so you find yourself looking into the documentation quite most of the time. So a request to the GraphQL API would look something like this. So we send a post request to the GraphQL API, and with this post request, we also send like a GraphQL query, whatever that is. We're going to explain it later. And then GraphQL takes it, the server routes it to the GraphQL runtime. I described it here as just another small server, because you have to think of it like another entity. And GraphQL will, oops, what happened? GraphQL will parse the query that you just gave to it, and will hopefully give you back the exact data, not more and not less, like not overfetching and not underfetching. So for example, if we wanted to get this view in our application, a query in GraphQL would look something like this. So this would query in GraphQL look like. So I just say, hey, I want to do a query into your database. I want to get the viewer, which is the current user. And from the current user, I want to get the list of repositories, the last 3 repositories, and the name of these repositories. So we can see them here. And the followers also, like, I want the last 3, and I just want the name. I don't need more information, like what is their age or email or what have you. And eventually, like, I'll get this list of exactly the data that I needed at one point. And this is kind of mind-blowing, actually, if you think about compared to REST. So the total size of a GraphQL query would be like 0.2 kilobytes, which is almost like 180, like 900% improvement from the REST API. So how does actually GraphQL does that? We discovered the problem of overfetching and underfetching, by the way, of REST, and also the n+1 problem, because we're just making one request and we're getting everything that we needed, and we're actually nesting the followers into the viewer. So I'm literally don't have to make more round trips into the database, into the server to get the follower and the name and what have you. So let's now address the problem of RESTful-like APIs. And to understand this problem is that you have to understand that REST is actually an architectural pattern. And I would like to put it in a simpler terms. Imagine the differences between a library and a framework. A library is just, if you want to make a table, let's say, for example, a library is a set of tools that allows you to construct a table. And then you can actually do the table as design it as you want and make it as big as you want or as small as you want. Whilst in a framework, let's think of it as like an IKEA table, right? The sizes of the table are already done. The instructions are given to you, because IKEA thinks that this is a really good design for this table, and it really works well. So it's not big enough to be like, let's say, for example, the weight is too much in the middle, and it's not small enough that you cannot do anything. So IKEA actually thinks that these kind of design tables are correct. But REST is not actually nor a library or nor a framework. It's a pattern, and people actually can follow the pattern or not follow the pattern. So you don't end up having like pure REST APIs. You end up having people just like developers just building RESTful-like APIs, but they're not actually full REST APIs. So you don't have a structure. It's not forced like in a framework. Whilst in GraphQL, in this query that we're doing here, GraphQL Actions actually parses the query and understands what is happening at each moment. And it actually tells you to build the API in a very formal set of ways, let's say. So it's not like REST, where you can just take whatever you want and do. For example, there's a huge confusion. People just think that returning a JSON from a server is a REST API. Well, that is not a REST API. We saw that it is much more than that. It's about the collection of data. It's about using the HTTP protocols and everything. And it's obviously much more than that. So let's see how GraphQL actually understands this query and gives you exactly the information. For that, you actually have to tell to GraphQL, you have to define the types of information that you have in your database. So here, for example, for each user, we will have to create the name, the email, the followers, the following, which is followers is going to be just like an array of users. This is a very common way to express a list of things. And the repositories is also going to be an array of repositories. Also in the type, you're actually enforcing what kind of type is going to be. So it's going to be a string. And this like really forces you to build to actually give back the information correctly, because if you're not giving it correctly, then the parse will just fail and it will just not give you the information. Whereas in some REST APIs, actually the documentation mismatches what the actual implementation is, and you don't really know what's happening. So you think that a field is nullable and you call it, and then it's not nullable, and then you don't know what you can actually do with it. In GraphQL, you actually force to define these types. And then you have to define also the query and the mutation. So just like in REST, we had like the get, post, put, and patch methods. In GraphQL, we will just have two operations that we can use: query an information or mutate an information. Query, like just to get an information, and you mutate to modify the information. So for example, create a user, delete a repository. So this is like a GraphQL schema, and you have to define it if you want to define your data type. And then you connect your GraphQL schema to your application. So your application would need a resolver to resolve each and every one of these fields. So for example, a name is a string, so you don't have to resolve anything. But a repository is a list of repositories, and you have to understand where to get that repository from. And this is actually what the resolver is using. So for example, if I'm fetching a user, which is here, if I fetch the name and the email, it doesn't need a resolver for that because it's just a string. But if I'm fetching a repository, I'll actually have to define how to get that information. So I'll just tell it, hey, if you get a repository request, take this function, which will actually take a parent. The parent is the user here, and go to the database and get me select everything from the repositories table, where user ID is the parent, which is the user that is calling this this field. So we can actually see that if we wanted, we in our query we could like request for this repository field, and the server would just go and get this information. But like, how do we also understand what is user? So we define how actually to get users from the database. And actually, GraphQL interfaces in your database and says, OK, if you're requesting a user, select everything from the users table, where ID is the user. And if in the user as well you requested a repository, go to the repositories table and get the information from there. So you have to define kind of the resolvers. And that would be it. This is all you need. And the cool thing is that because you already defined the types, if you're using a language like TypeScript, you actually can autocomplete most of the things because the types are already built. And in a dynamic language, this is a really good way. Sorry, in a static language, this is a really good way to be able to program correctly, let's say, which is all what types are there for. Something cool that GraphQL gives you is an interface, a GUI interface, where you can actually, because we said that GraphQL is a server running Nest or a runtime, running also at the same time as your server. It actually gives you this GUI interface where you can actually start testing your queries. And you can see here, I'm just requesting the name of the viewer. I'm not requesting more information, and it's giving me the exact operation. But if I needed more, I can just even autocomplete because, again, the types are defined. And I can actually get all the information that I wanted. And this is really cool. This is like already self-documenting API. We shouldn't fall into the idea that, OK, just because it's self-documented, then it doesn't need a documentation from our side. But just like good code, GraphQL just tells you what kind of things you can expect from it and what kind of things you can use from it. So here we just like, with GraphQL, we have a more, because GraphQL has to understand, and we have the types, and the queries are actually parsed by the GraphQL parser. We actually have like a framework of how to do things, and you are enforced on giving back the information. So you don't have anymore this RESTful-like APIs, the problem that we had with REST. So again, we were saying this is like the final view, and this is like really beautiful when you're developing, and you're developing that page and you just wanted to get that information. It's a really easy way to develop. So again, to wrap up, we would say that GraphQL is an API query language / I would say framework, even though many people wouldn't agree, compared to REST, which is just a pattern. It's also flexible, because imagine that you're building a product from ground up. It's really good that REST APIs can last for decades because they're really well built, and you have to put a lot of thought into the process. But what about the beginning phases of creating a project? Sometimes you just see the need of creating more information and putting more information into the API. And if you were building it in REST APIs, the backend team will have to implement the new fields that you want to add, and the front-end team is kind of stuck in these new fields until the backend finishes, and then they can start using them. Whilst in GraphQL, you can actually use the fields that you want to use, and if there are more fields, then the server will just ignore it, and you can be more flexible at the beginning of a project to make it grow as much as you want, but also to make it maintainable for a long term. And finally, it's network efficient. It's not only network efficient from the client side, like the N+1 problem and the overfetching side. We can actually also optimize the server side, like how many queries do we want to make to the database, and we can actually reduce the number of queries to the database to one query. Whilst in REST APIs, if you remember correctly, for each request that we had to make a new request into the database. So will GraphQL replace REST? If you heard this talk, you might think that it would. But obviously, the correct answer is that GraphQL solves a specific problem with a specific constraint. So GraphQL is just a tool, and REST is another tool, and RPCs that we saw earlier are other tools. And actually, RPCs are pretty much used these days. Don't think that just because the problems that we showed, they're not used. They're heavily used in microservices, and with Google releasing the gRPC framework fairly recently, which made it even more popular. REST is a tool that solves a problem, and GraphQL is another tool that solves a problem. So, and there's no silver bullets. There are some cases where REST really is just above GraphQL. And some cases also when you need network, if, for example, one of your problems is you need network efficiency, then GraphQL might solve your problem. But you actually have to see the entire set of constraints instead of just one simple constraint. So yeah, these tweets or these people that say that GraphQL is going to take over REST, it's just like sensationalism in the way of in the world of developers. And with that, I thank you for attending to this talk. We have 10 minutes to ask for questions. So let me know what you thought. What kind of questions do you still think that you would need to understand? And actually, you can go, we have some information here. You can, if you want to make more questions, you can go to slido.com and enter this code, and you can put the questions. Not probably a question, but will these slides be available to the public? They're amazing. Oh, thank you. I don't think that I'm a good designer of slides, but yeah, thank you. I'll talk with the team, and probably they will just upload these slides into the website. Although the response from a REST API has more kilobytes when compared to GraphQL, the request to a REST API has probably less kilobytes. That could be true, yes. If you think about it, yeah, if we, for example, we're making a GET request, and that's actually fairly pretty much less than the information that we return. Again, think that in GraphQL we have a query, and we send the query with the GraphQL in the post. Sorry, so in the request. So yes, it does have REST does have probably less kilobytes, but you can actually cache the GraphQL queries, and you can just use them very easily. So so yeah, there are some ways to make the GraphQL queries really very, very small. The difficulty to integrate GraphQL in a web project differs if it's like Vue.js or PHP. Actually, there is an implementation of GraphQL for many languages. And again, like this is something that I haven't mentioned, but GraphQL is a specification. So Facebook, when they released it, they haven't released a tool. They haven't released something specific. They just released a 15-page document explaining how GraphQL should be looked like. And then you have the community actually working on adapting these specification to specific languages. For Vue.js, I'm 100% sure that it exists. PHP, I'm fairly sure, but I'm not entirely sure. Oh, that question just disappeared. But the cool part of all this is that because Facebook is not building the tools and the community are building the tools, you actually don't have a project only like self-sustained by a company. You have a large set of communities behind it. So also continued, also request to REST APIs looks simpler and easy to format. Am I right? Is the GraphQL always the best option? Again, as I mentioned, GraphQL is just a tool to solve a problem in a specific case, and we actually just mentioned what are the things that GraphQL is good at. But for example, in a REST API, you can actually use the browser caching of the GET requests because you can. This is an advantage of using already built-in protocols that are already there. So again, each tool solves a specific set of problems. So it's not always better to use GraphQL over REST. Imagine you needed caching in the client side, so it's really good to use REST in that case. What do you advise to start learning? Sites. So I think I could add to this slide, at the end of this slide, some learning resources that I actually found useful in my process of learning GraphQL, and I can share them with you with no problem. And finally, good friend Jesse is asking, how would a complete noob accomplish learning some technology like this, given that this is only used mainly in great projects? No, this is not actually used in great projects. I would say that perhaps GraphQL requires a little bit more of programming resources at the beginning to set up the GraphQL server and to set the entire infrastructure. But actually, even in your small projects, you can start building them. If you remember, one of the last points that I mentioned here is that GraphQL is flexible, so you can actually start really small and then grow them to whatever you want. So yeah, thank you, Jesse, for the question, and thank you all for the interesting questions that I've mentioned. Let's wait for a couple minutes and see if there's more questions. Again, if you want to ask, slido.com, and enter this code that you see here, 505050. Very interesting question. Oops, sorry guys, I didn't share my the question slides, so let's share it now. There it is. What has surprised you the most? Honestly, the ability to be able to work. Is there any lab for try online? Yes, let's actually just do them. There's nothing better than live coding. So let me just go to the GraphQL API here, the GitHub GraphQL API, and we can request it. So I'm going to share my screen in a second, so just give me a second, please. Root endpoint, playground, and there it is. Now I'm going ahead to share my screen. Okay. GraphQL Explorer. So as you can see here, this is like a very simple query that we can make to the database, and we get the information that we want. Also, if we don't know what viewer is, the GraphQL GUI interface gives you an ability to check the type of what is returned actually, which is pretty amazing. And I would say that is one of the things that I actually like from it. So you can click here and see what all the information that is being given back. And actually, you can just say, OK, autocomplete email. I request that, and I literally get that information. So let's say, for example, we wanted to get the followers as well. We would go here for followers. Let's say the last 3 followers, and it would be something like we have the bio of the followers. So let's just get the bio as well. And we want to get the email, for example. Well, this is not a good idea in a live session. But the name, yeah, let's get that. And here, like you can see some of my dear friends, Tarek or Sergio, on their bio. So the ability of being able to work with the API this way and inspect it and being able to autocomplete, it's just mind blowing. And if you use TypeScript and you join the types of GraphQL and TypeScript, and then like literally you just have the opportunity to autocomplete in your project, which is always great. What do you think is the hardest thing to manage in these projects? I would say definitely in GraphQL API, you have an overhead of any new thing that you want to add to the API. You have to first create it in GraphQL. You have to define the types of it, and then you have to go to the server and to the client and implement it in the client side. So I would say that maintaining the GraphQL server up to date is the only hardest thing to manage in these kind of projects, and it's like also an overhead. But yeah, again, it depends on your use cases. So if we don't have more questions, thank you all for joining into this session, and Carlos will take over right now.
So Abdallah, thank you for your presentation, and also Ismail, that of course elucidates us fantastically about the tool GraphQL, and then also about the impact of your community, and this amazing presentation and the powerful message can be a trigger for anyone that is seeing us, and inspire and be a trigger for someone that can also and would also to join to close this community from them, and also contribute and share knowledge for their community.
Yeah.
Thank you, Abdallah.
If you allow me, Carlos, I would like to add that I'm just another developer in my community, and the only difference between me and my community is not that I know more, is that I wanted to share some content and the things that I learned. And the same way that I shared content with you right now, you can actually learn a new technology and share that content. And it's actually a really interesting way to learn something, because if you say you want to give a talk about it, then you put a deadline and you actually learn that technology, opposed to just saying, hey, I want to learn it, and then getting it later in the future. So yeah, and also like the photos that we've seen in the beginning, like Ismail shared about our community, we not only used to make these kind of big events, we actually used to make like something called in Spanish tecnotapa. So it's like technologies and having tapas in Spain. So we were just like gathering in restaurants or bars and having a drink together and talking about technology. So yeah, it's amazing what the community can give you, and also the amazing work you Carlos are doing with the community, because this is a huge work to make online events, and you've already streamlined it to make online events seem easy, but it's not that easy.
Yeah, of course. So part of this project is just hosting the events, but of course, the presentation that you made and the previous speakers are the main core of this project. Because without you and without the people that are assisting us, this project doesn't make sense at all. So I just take this opportunity to thank you, and also to thank all the people that are all seeing us, and of course I hope they enjoyed, of course, your content. So again, Abdallah, thank you a lot for being a speaker of this tech session. Hope you enjoyed it a lot, and let's go wrap up this event just to announce the next tech session. Then it will be from the Rustam from the GDG Cloud Oslo, with an overview around the Apache Beam. The session is scheduled for the 30th of September, but stay tuned to our social networks for more information. And don't forget that your community can also propose a tech session and be just filling this form, and we will contact you to get all the things ready. And just to finish this tech session, thank you everyone, but just to asking you to follow us on our social media to get updated on the last news. And again, thank you, Abdallah, thank you, Ismail, and thank you, GDG Jaén, for being this session for today. And thank you everyone to joining us. Hope you enjoyed a lot and hope to see you soon. Goodbye.